Alright gang, let's take a look at 57. So the derivative of this is going to be 1 minus 2 cosine x. Alright, there are no domain restrictions on this function, but, let me watch what I say. They are keeping you on the domain. It says in the top part, you want to stay between 0 and 2 pi. So that's important to note that, because this actually otherwise would have an infinite amount of extrema, okay? Because it's an oscillating, repeating type function. So they're going to keep us on a particular cut. Now this one is oscillating. Okay, so now let's do any critical numbers. So for the critical number, it's not that they have to have max or mins, but if they do, they tend to be repetitive on oscillating functions. All right, I'm just going to move this to the other side. I'm going to divide off the 2. Okay, let me just write it that way. All right, now how you guys did this in pre-calc was the first thing you had to notice is that this was positive, and that told you what quadrant you were in. So cosine is positive in the first and fourth quadrant. Cosine is negative in the second and third. Okay, positive in the first and fourth. Then you would note what two sides you were given. So this is the adjacent and this is the hypotenuse. So the adjacent is 1, the hypotenuse is 2, and you memorized that the third side would be a radical 3, right? You guys memorized the two triangles in the unit circle. I gave you guys the notes on this at the beginning of the course. If you guys need me to like repost it under this section, just let me know and I'll go dig it up. Alright, so now you know if you're across from radical 3, that's 60 degrees. I'm just going to write that in radians. So that means that theta prime, the reference angle, is pi over 3. Now you have to do theta, which is the standard angle. So remember, this one's the reference angle. That's an intermittent step, and like a middle step. And then you write from that the standard angle. The standard angle has to start in standard position, which is the positive side of the x-axis. So in quadrant 1, the reference angle and the standard angle are equivalent, which means that our first angle then is pi over 3. In quadrant 4, you have to calculate off of the reference angle what this would be. So you have to revolve all the way around to here. So you're short of getting to 2 pi by pi over 3. That's what you're short by. So you do 2 pi minus pi over 3. You get your LCD. All right, you get your LCD, and that means that your second angle is 5 pi over 3. Okay, so now we've gotten to the answer of part A, which is what are the critical numbers? And the critical numbers occur when your first derivative is set equal to 0, which is what we just did. So your critical numbers we just found. So, oh, you know what? Okay, I'll leave it like that, but they're x's in terms of this problem. They're not using the variable theta. My brain just switched to theta temporarily. Okay, but let me write it as an x, because the original is in x and not in terms of theta. All right, so those are the critical numbers. That's where this derivative equals to 0 on this particular domain. All right, so now let's move to testing it. All right, so now this is the part where you draw the number line. Now, I'm not going to put arrows on the end of my number line because my domain here, right, is from 0 to 2 pi. So I have to stay within that constraint. And within this constraint, I'll go ahead and put my critical numbers up that we got. This has no VAs in it, no vertical asymptote, so I don't have to worry about that. So remember, the only place you can have a max or min, the only potential, doesn't have to occur. The only potential place you can have a max or min is at a critical number. So now that's what we're going to look to see what's happening here. So let's see. So just because this might help some students, radians are sometimes a little difficult. This is 60 degrees, so I have to pick something to the left of pi over 3, which is 60 degrees. So I'm going to pick pi over 6, which is 30 degrees. So I'm